Okay, hi everyone. Welcome back to the last group of videos on how you can analyze your training data from this from these the 6 weeks that you've been running. So if we get directly into it, we start up our studio again, and we open our analysis project. Last week, well, we started to look at doing some exploratory data analysis. So we were looking at just kind of starting to look at your data, which should always be the first step. Both how to look at per day. So we load the data, and then, for example, here to look wellness data, how it evolves per day, and depending if training and this way. And we also checked a bit about the training data itself. Check TRIMP, and then we quickly saw a little bit how you can start to look at relationships between two variables, and how we use the lead function to take the value from the day before. So today we're gonna continue. We're gonna look a little bit more on how to do like how to do parts that you're gonna need for your final analysis. If we if we have a quick look at what you're actually supposed to get done, if let's pull up the actual written report. You can see here, if we look in the results, we should include some kind of training compliance, which we looked at last week, right? With the training load. Does the training load, training volume, training intensity match what was planned? And if not, why not? To mention that or discuss that. We're going to look at the physiological response a bit, and how that might differ. You need to show how that maybe differs by training block, how it and so forth. And then the wellness trend, so for the wellness variables, to show maybe how they differ by training block, but also maybe how the trend look over time, right? So we get into it. Let's start by creating maybe a new R script for now, and save it as like 03. We could say create output. Same here, we know from the first parts are going to be the same. We're going to need so we load packages library. We know that we're going to need readr to read we know that we're going to need dplyr to do some if we need to change the data somehow, and we know that we're going to need ggplot. Now we can load read the data. Here we can again take the same as last time. First thing we're gonna look at today is how, for example, that you could use some kind of reference lines. So we could, for example, include this is the way you could include, for example, information about training volume, like the training volume or training intensity for the different blocks. But you're gonna you can do that similar way, but I'm going to show how you can do to include the mean, so the average of a block or a week in the plot, and also get it as a separate output, as a table. So we're going to look at we can call it remember from the fall, naming is always one of the hardest things, but let's call it reference lines, for example. So we look at our daily data, and I'm going to show this for kind of one variable, but you could do the same for several variables. So we could take the we could for example do the two DFA alpha 1, so in rest and training. To do that, remember that then we take the tidyr, because if we want to include several variables in the same graph, we need to put them in a long format where we have one column with the variable name and one column with the name of the values. So we're going to take our daily data, we're going to pivot it longer, and now we're going to say that we want our columns, we want it to be rest DFA alpha 1 and training DFA alpha 1. So probably you're going to want to do this for more variables, or one option is to show them by, for example, by group of similar type of variables. But here is where you have to make your analytical choices. You have to choose which variables are interested to look at, how is it interesting to group them, which variables are interesting to look at in which way. But so if we just run this and look at it, it's obviously too long. Remember that we can use pipe into the view just to see it without having to save it. And now you see here we have name and we have the value for the days that we have values for them. So now what we're actually going to save this one as data long DFA alpha 1, just so we can use it for 2, because when we want to create these kind of reference lines or summary statistics inside, both for creating the table and for showing in a graph, it's easier if we summarize the data in its own place, and then we do it in the we add it to the plot. So we're going to take this now, and what we said that we were interested in this case is, for example, the average value in each training block. We could take the average and standard deviation. So we're going to group by, and now we have to think here a bit, because when we look at our data, we have to remember what do we actually want. So remember, when we group by, it's like, what should we have one line for? And we want one line per training block, right? But since we work with this in a long format, so we have the different variables, then we also want one line for each of the two variables, right? So we want to group by name, which is the standard in pivot longer. You can give it another name, but let's call it, actually, well, sorry, let's do it this way. Actually, let's just to make it a little bit clearer. In pivot longer, remember that we can decide what we want to call this. So we say names2, and we call this one variable instead. Now we run this, and when we check the data, you will see that now it's called variable instead, just to make it maybe a little bit clearer that we have that this is referring to the variables. So then we want to group by variable, and we want to group by, let's see if we call it block or training block. And then we want to summarize. And now we want to summarize our value, and we could then do, we probably want our mean, so mean of the value for that training block and variable, right? We run this now, and we get mostly missing data because we have a lot of measure. We have some places where we actually don't have a measure, so we need to do the we're just gonna ignore those ones. Okay, so now we have the average values. Perhaps we want the standard deviation as well, right? And then we can just use SD value, and we know that we're gonna need to remove these ones. So here we have first of all, this could be, you could save this as a table if you want, or either save it as a table or use this as a table, or putting the values into your report. Like, so here you actually have the values. That's the first thing we could do. And here, if you are so we're actually going to save this one as data summarized DFA A1. We save this, and what we can do with this now, if for example we want this for a table, so if we just open it this way, or we open it here, you see that we have all the decimals. So here, for example, one option you could do, just to make it a little bit easier, is if we mutate the mean, we can use the round function, and then the round is first just the variable that you want to round, and then the second argument is digits, which is how many digits do we want to round it to. So in this case, perhaps 2 digits would be, and this is a 90. So this is just an easy way to get the right amount of decimal places for presenting, not to have to do that calculation by yourself. And then we would probably do the same for the standard deviation. Okay, so that's good for kind of being able to present by block, by training block summary by mean or standard deviation. You could obviously also do this by week instead. So if we run this, but instead of training block, we do it with week, we will get 1 per week. So that's easy way to do that. But now, if we now want to plot this, we would want to take our raw data, not the summarized one. We can do. We would take our raw data, because we always want to try to show in plots the raw data as much as possible. So we would do ggplot, and on the x-axis we would have our date, and on our y-axis we would have our value, right? Because remember, this is the pivoted version, so we have, if we look here, we have our values for each of the blocks. And then let's say that we want to show this with some points, maybe, so like dots for each value, for each day could be an option. And then remember that we need to facet wrap or facet grid. There are two versions, and then the shorthand to do in facet wrap is just do a tilde and then put the variable, what we want to split into separate plots on, so which variable, and in this case is the column that is called variable that we want to split. So if we run this now, you will see here that we have the value from each day here. We would maybe, if we just want to do it this way, we could consider instead of geom point, maybe geom call, just to get, it could be a little bit easier to see sometimes. That depends on you. Here it's interesting, in REST we have a couple of days that are pretty high values. So maybe what we would be interested in doing here is to actually have a look at what happened this day, or maybe the day before. Like, are there anything that sticks out that is more extreme? And then when you see that, if you see some, then you can start to, for example, plot that relationship, because you saw something that looks like it makes sense. But in this case, what we are actually interested in doing, because of that, let's go back to do geom point in this case. Here, what we could do is, what we might be interested in is actually doing a reference line, like having the mean value for each of these blocks. So what we would do then is to say we want a geom line, or we could actually even do a geom horizontal line, I think. Let's try this one. You see here, this is where a lot of times things comes down to trying and see how it goes. So in this case we are going to use the summarized data. So we are actually going to use, as you see here, in this geom you can add a second data frame, and that's what we're going to do now. So in here we're going to say we're going to put data equals, and then we're going to take our summarized data. Now the problem here, if you try to do this, is requires the following missing aesthetic: y-intercept. So if you look at the help page here, which is a good idea to do most of the times, and we scroll down here, and you can see aesthetics. Different type of geoms take different type of aesthetics. So for the point, for example, it was just a y value, right? In this case, since it's a horizontal line, it's going to look for a y-intercept, so where it should intercept the y line. So we're going to add aesthetics, and we're going to say y-intercept equals the mean, right? Is the mean value here. And now you see that we have a problem that it's we get multiple lines here by, let's see if we get 3 lines, right? These are our 3 blocks. So these are our 3 training blocks, but we have them in all across the plot from the first to the last date. There are a couple of different ways to handle this. Like this is one of the advantages sometimes, that you could do things in several different ways. One option here could be to perhaps like in this case, one way could be that we actually create separate plots for each block. So if we here change to facet grid, and then in this case we could say for our rows, and again go in and look at the help page or search online, we want a row for each value in the variable column, right? So if we just run this, we get a problem, which, let's see what, like this. Now you see that we have our two variables on a row instead. This means that now we could do for columns, we want to put each training block. So now you see, now we have block 1, block 2 and block 3 in different plots close to each other. One problem here is that you see that we have the same kind of scale in all, right? So we have from 1st of May until 1st of June, but the training blocks doesn't have that, right? The training blocks are only part of some of the dates. So what we could use then is what we looked at last week, scales, I think it is. If we go into the scales, and then we can say we want free X. So we want the X scale to be free to only cover the dates included in this. So this is one way to do it. Now you'll see that we have our we have our reference line for each of the blocks. So this is good. Another way to do this, if we go back, would actually be then to so we want our would actually be then instead to put this data back. So we know that we have, if we look at our data summarized, we have one row per training block and variable. Now we could join this back into our raw data. So if we would take our raw data here and then we do a left join, and we do we want to left join the full data with the summarized data. Most of the times if you just run it and then you normally get this tip, this is what it's trying to join by, and in this case by training block and by variable. That's correct, so we put that in just to. And now, well, if we look at this data, you see that we have the mean and the standard deviation for each day and variable. So if we now so now we're going to work, if we just run this without the GMH line, we get the same as the first one. But now if we add a GMH line, and again the aesthetics should be that the y-intercept is the mean, right? Because if we're remembering, we joined these ones together, so now we have our mean column by each date. We're gonna see if this works. No, we're back to the same problem. So here, one option, again, when you need to try things and discover, if instead of the horizontal line, because horizontal line says take the y-intercept, like where on the y-axis, and just draw a line. But we could use the GM line that connects lines in order. And if we would run this now, we get a line between each of the points, which maybe we would be interested in another case. But that's not what we want right now. The problem here is now we're back to the y-intercept, because the GM line, when you look at the aesthetics, it doesn't have a y-intercept, because it doesn't look for a straight line. It looks for a y value and an x value. So we just change the y value. The x value should be date, right? And now we're starting to get somewhere. We have one line in 3 different. The only thing is that they are connected, and that probably is not the right choice. Before we check that, you don't actually need to write out. You see that this x equals date is the same as the general one we put up here. And as long as it's the same as the general one, you don't actually need to put it in the aesthetics for each geom. Like here in geom point we didn't put anything. Then it takes this x and this y. For the geom line, we want to change the y, right, to the mean, but the x is the same. So this one we don't actually need. And now, again, it created this line that goes this way. One thing we maybe want to do here, though, is is to break it between the different blocks. This we could do if we use the group. So we want to say we want to create one line for each block. Training block. This way. Now you have a reference line for each training block. We could, even in this case, just to make it a little bit clearer what we're doing, perhaps we could say that we have one color for each training block. Probably you will want to change the colors and those things. We can look at that a little bit after, but now you get and here we can start to see these differences. One more thing that we could do is try to display the standard deviation value in this, and to do that, we would then need to have like a range, right, from which is the lower standard deviation, like to the higher. So to do that, we would do something like we need to calculate. Not here, sorry. This is let's remove this actually. That was just the rounding variables. Here, so then we could do something like lower, because if we now just if we look at this data, the summarized, you see that the standard deviation is just it's on a standard deviation scale. So what we need to calculate is like what would be to make a band of the standard deviation values. We would need to do something like take the mean plus the standard deviation, or plus half the standard deviation if we want half the standard deviation to be above and below. So then we would take, in this case, we would do something like lower equals mean. We take the mean value minus the standard deviation, and probably what we want, if we want to display like one standard deviation up and down, then we would do half the standard deviation. Now we do the same for upper, and we take the mean plus half a standard deviation. And if we look at the data now, you see that we have our lower and our upper, and then you can see that the lower in this case is taking the mean value and take away half of this. You could do this not only for standard deviation, you could display standard errors, and you can calculate, you could do 95% confidence intervals as well. There are several ways to do it. So if you want to put that, just search online, because you're going to be able to find it, the exact way to do that. So now when we have this, and we want to add them here, we're gonna add one other geom, which is gonna be a geom ribbon. So a ribbon is basically one that just have a minimum and a maximum value. If we check here, geom ribbon, and then we check the aesthetics, a y minimum or a x minimum, depending on the orientation you do it in, and then y max. So here we could then just put, we want the the y min, so the lower, to be our lower value, and our y max to be our upper, right? Remember, from the data that we then joined in. If we run this now, you will see that we have these ranges this way, right? So you see that here, for example, the standard deviation of the third block of training DFA is a lot smaller than this one and this one. And this kind of gives you a little bit of an intuition. It's not a statistical test, remember that, and you shouldn't just look at if these overlap or not, but they give you a little bit of an indication that, for example, you see here that the resting, the first week is kind of different from the second week, while the second and the third week are not as different from each other, right? So this is a way to not only look exactly at the difference between the mean values, but also take into account the amount of randomness. But this doesn't look so nice. The problem here, there are two problems. The first one is that we have these lines at the end, which probably we don't. And this is because we said that the color, it should be colored by training block. In this case, for the ribbon, we probably don't want that. So then we would say color is NA, so missing, I think. No, we want color to be, let's try null. Then you see that then this disappeared. The problem here is that now it's connected because it doesn't actually separate it anyway. But what we probably want here is the fill. So for these kind of geoms that have area, we have, if we put the color, we're just doing the borders, but we actually want the fill to be equal to training block. And now you see, now we get this range in the same color as the training, but it's it blocks out everything completely. So that we don't want. So now remember that everything we put in aesthetics is what we want to map to some kind of data. But apart from that, now we just want this to be a bit transparent. So then we would set alpha. Alpha is transparency. We could start with like 0.5. Now you see that we have the mean, the standard deviation, but you see the things behind. So this would be one way to show standard deviations, like mean and standard deviation. And again, you could do this for your training variables. You could do this for basically about anything.